C99 tutorial part 4 continuation. Let's continue our discussion of standard input and output. To demonstrate this, let's write a simple program which copies the standard input into the standard output. To accomplish this, we need two functions from the C standard I/O. We need Getchar and putchar. Getchar, like the name suggests, will get a character from the standard input, and putchar will write a character on the standard output. Notice the return type of Getchar is int, for integer. And putchar, actually notice here, putchar should accept as an input an int called C. So what it will do is it will write the character represented by the int C to the standard output. One more concept we need is a special character called EOF. EOF is not an actual character, but it stands for the end of the file, or the end of the input. So if you ever read from Getchar and you see it's EOF, then you know it's the end of the file. So what's the task of our program? I want to read standard input and put it on standard output. So I'll call it in2out.c. Before we write the code, let's write pseudocode and lay out the steps that we need to do. Typically, pseudocode should describe very abstractly how the task is to be performed, so we don't have to worry about the language details. So first let's define the task. Copy standard input to standard output. So how exactly do we accomplish it? Let's do this. Read a character while the character is not EOF, then do the following. Write the character, and then afterwards read a character. And that's pretty much our program. Just for clarity, let me replace this here, do the following, with the sort of C notation, the braces, to make it clear what we're doing inside the while loop. So the pseudocode summarizes the program. While the character is not EOF, read a character, write a character. From looking at the pseudocode, we're pretty confident it should do what we say it will do. So now we just have to convert this from pseudocode into a programming language, in this case C. So let's save this and then go into our projects chapter 1 directory. So cd chapter 1, and then let's open the Explorer again, so start period. So as I mentioned before, this lets us open the Windows Explorer window, which is nice for managing files. Alright, so let's make a new file now called in2out.c, and we'll use this for our program. Let's copy and paste the pseudocode into the source code file in2out.c. Then we can simply make it a comment. Now we know already we need standard io.h, so let's include that. Also we need the main function prototype, so let's type that in as well. And then give it the standard parameters int argc char star argv bracket. Open curly brace, close curly brace. So now we have an outline for our program, and all we have to do is do the pseudocode as C statements. So first is reading a character. How do we do that? Use Getchar. So let's write Getchar, but we need to assign it somewhere. So we'll write C equals Getchar. Let's return briefly to the function calling convention. What this is called is a prototype of the function. It specifies how a function should be called, for example, what arguments it requires and what arguments it will return. And we see here C should be an integer, so we should write int C equals Getchar. So next step in the pseudocode, while not end of file, so let's write this in C language, while C not equal EOF. This exclamation point equals notation means not equals. Let's write a curly brace afterwards. So next is write the character, so that's putchar C. And then next is read a character, so C equals Getchar. So I think that's it for our C program. Let's save the source code and try to run. And like last time, let's write the compile command at the top. So that's gcc -wal -wearer -o the output file name, which is into_out.exe, and then the input file name, into_out.c. And like I mentioned, we type this here so we can learn the command parameters for GCC, as well as so we can simply copy and paste into the command prompt. Okay, so notice when I try to compile it, I get an error. Control reaches end of non-void function. So let's fix that. So this message simply means we forgot to return a value. Remember, int main must return an integer. So let's fix that here, return 0. Remember, 0 simply means to the operating system, no problems happened. So let's try running the program. So when you first run it, it may seem like it's not doing anything, but it turns out it's actually waiting for some input to come in from the standard input, which is the keyboard. And of course, standard output is connected with the screen. So it will read something from the keyboard and write it on the screen. So let's try typing hello. And then as a result, we see hello back on the screen. So I type 1, 2, 3, and I see 1, 2, 3. So whatever I type here, it will be copied to the screen. So how does our program end? Remember, our program says while C is not equal to EOF. So how do we type EOF? EOF is not a character. EOF is the characters E, O, and F. So how do we actually signal the end of the file? So if standard input is connected to the keyboard, it turns out Windows gives you a key combination to signal the end of the file. That combination is Control-Z. So simply type Control-Z and press Enter, and it pretends it's the end of the file. That is, it signals that this is the end of the file. So remember previously I mentioned you can redirect the standard input. So let's try that here. Let's use this notation and redirect standard input to come from infile.txt. And the infile.txt simply has some input that we've already prepared. And this one has 2 lines of text, which we'll use as testing input. So if we run it like this, we read from the infile for standard input, and it puts it on the screen because the screen is standard output. So let's try redirecting standard output as well. So if we do both the less than and the greater than, then we can redirect standard input from one file and direct the standard output to a different file. So basically what we've done is we've copied in file into out file. So here it is. Here's out file, and when we compare it to in file, we see they have the same contents. So we've copied standard input to standard output. One more variation on redirection is by using a pipe. So in a pipe, we don't have to specify a file to redirect it. So here's how it works. First, we need a command that produces some output. So let's use our far program from before. For example, when we give this command, far 0, 20, 20, this command gives 3 lines of output. So the pipe simply means this. I want to take the output of this program and redirect it as the input of a different program. So here's how we can do that. Use the pipe operator. The pipe operator is usually on your keyboard together with the backslash key. So find the backslash key and press shift backslash, and that's the pipe. So let's run the program far 0, 20, 20 and pipe the output into our into_out program and see what the result is. So what's actually happening here? We get the same result as last time, but what it's doing is the following. The output from far is going into the input of into_out. And of course, into_out takes whatever's in the input and puts it on the standard output. Standard output is the screen, so we see the output on the screen. Notice that into_out doesn't actually do anything useful, but it's just for demonstration purposes. Similarly, we can combine the output redirection and output the output from into_out into a file. So altogether what's happening is we're running far, it's producing output, it's being read in by into_out, and then into_out is redirecting it out to a file. And if we look, here is out file, and if we look inside the contents, we can see, as we'd expect, it has the result from far. So this idea of a pipe came from Unix operating systems, and it's quite a useful idea because it allows us to make separate programs and then combine input and output from separate programs together to produce a more complicated program. Let's give an example by using our in file together on the pipe, or on the same command line with the pipe. So if I use this command and I try to pipe the output from into out, into out, and I can again pipe it into out, then I can make what's called a pipeline, where the input from one program is being taken as the output of a different program. So for example, our input is basically being passed from the left-hand side to the right-hand side, eventually getting all the way over to the output file, which is out file. And that concludes part 4 of the C99 tutorial. Stay tuned, we'll talk about a different topic next time.